Hello. Today's lesson is going to be quadratic function. In this lesson we're going to take a look at the formula, the properties, and the main goal is to learn and remember how to draw graph of the quadratic function in coordinate system. So let's start from the formula. From the beginning, this is the formula. F of x is equal to ax squared plus bx plus c. Why is it called quadratic function? Well, similar reason why quadratic equation is going to be called quadratic equation is because x is squared. It's the second degree function, so to say. And we still have the coefficients a, b, and c. Now these coefficients have their own specific terminology. For example, coefficient that is next to x squared or that multiplies x squared is going to be called leading coefficient. Meantime, the coefficient that comes with the x is going to be called linear, and the coefficient that is without x without x is going to be called free coefficient. Now this is considering the names. Now, of course, these coefficients are going to be numbers, any real numbers, and when we are going to do things like drawing and going into all that part, we are still going to have to calculate using the calculator or with the method I've shown you in the video yesterday. So now let's talk about the graph of the quadratic function. A quadratic function's graph is called parabola, and parabola is a curve that looks like one of these two. Now, what is the difference between these two curves? Well, it's considering the leading coefficient. If the leading coefficient is greater than 0, then the parabola will be turned upwards. If the leading coefficient is a negative number, the parabola is going to be turned downwards. So these are two specific situations, and I'm going to show you both of them in drawing itself. Now this parabola is I would say, a more specific curve than not. It has some specific properties that some other curves may not have. So let me draw now this curve one more time here. The idea is to be able to draw it in coordinate system precisely. So let me also now add the coordinate system into this picture. Now coordinate system I'm going to draw like this, somewhere on a side. And let's go like this. Now this is just a sketch. Don't mind me, it's not precise. More about it later on. Now a couple of things concerning this parabola. This parabola has a specific point which we can say divides it into two symmetrical pieces. Now this point would be somewhere in the middle, quoting. It's not actually in the middle. And it is actually the point that is the lowest in the whole curve. Or let's look at the sketch before, so it would be somewhere like here. Or it can be also the highest point in the curve. So before it everything ascends, after it everything descends. In the first case we start with descending, and after this point things ascend from onwards. Now in the coordinate system this point is specific, and it's called, considering the parabola, vertex. So let's name it. It's usually letter T, and I'm gonna say it is the vertex. Now I'm going to now advance it a little bit. So why is it symmetrical? What is the symmetry in all of this? Where there is if I draw a perpendicular line or vertical line, we can also say perpendicular to the x-axis, or vertical in a sense, like it's vertical. The left side looks like it's the mirror of the right side, or right side is the mirror of the left side. Doesn't matter what it is. And the important thing is that this axis of symmetry goes through the vertex. So vertex is the central point in all of this. Now let's talk about drawing and how to draw the graph itself. Now for us to get into it, I have to make certain preparation for that, and then we're going to go into the tasks and see how we draw it. So vertex is the main point. We are definitely going to go and draw it as one of the points we need. When you want to draw a curve in coordinate system, the least amount of points you should work with is 5. So the goal is to get 5 points, and then when we have 5 points, we can connect them into the curve, and then we have a graph. Now, one of them is, as I said, the vertex itself. So it's going to be definitely one. Now, how do we calculate the coordinates? You need x and y coordinates for the vertex. So there is a formula for that, and it is going to be for the x. For the x1 is going to be minus b over 2a. This is going to be the x part. The y coordinate is going to be 4ac minus b squared over 4a. So this is the formula for both x and y coordinate of the vertex T. Now we need 4 more. We already have 1. Now we need 4 more points. Now the easy ones are going to be, well, we have intersection between the x-axis and the parabola in most of the situations, and I'm not going to fuss you about when that's not going to be the case. So definitely we're going to have a situation where the parabola intersects the x-axis. So these are going to be the x-intercepts themselves, and they are also going to be called zeros of a function. I'm not going to write it down, but in the tasks themselves you're going to see how we get them. Now the idea is, since this is the x-axis, this means that whole this thing is equal to 0. Why? Because f of x equals y, so y is f of x, and y value on the x-axis is 0, just on the x-axis. Everywhere else it's different. It can be positive, negative. This is the y. These are the y values, and here is the 0. So all the points on this axis, they have the y value 0. So this means that ax squared plus bx plus c equals to 0. So we got that from these 2 points. Let me show it here. So this means that we have x1, x2, in the background, x squared, ax squared plus bx plus c equals to 0. We got that from all of this. So we're going back to solving quadratic equation. So this is why we need to learn the quadratic equation in order to then advance into quadratic function. So we use the formula minus b plus minus square root of b squared minus 4ac over 2a. So we use this formula. Now what happens is we get x1 and x2. We get these points, x1 and x2. These are going to be called zeros of a function, or x-intercepts. Now we have from 5 points, now we know 3 of them. We need to get at least 2. Now starts the easiest part. Now, so far we had to use specific formulas. Now starts the easy part. Similar to the x-axis, we can also look at what's happening with the y-axis. On the y-axis, parabola also intersects it, and intersects it in this here specific point. Now this here point has a specific coordinate. It's easy enough, no fuss about it. It's always going to be the value of c. Now whatever the c is, this is going to be the c. So on the y-axis, we find the number where is the c, we point it out, and this is going to be the intercept. So the free coefficient is also going to be called y-intercept. It's also going to be called y-intercept because of that. Now we have 4 out of 5. Now how am I going to get the last point? Easy enough. Once you have the c pointed out, draw yourself the symmetry line, and opposite to it on another side, in, so to say, same spot, we have another point, and we can just copy paste it, so to say, mirror it, would be more precise, and we get the 5th point. And this is how we draw graph of the quadratic function. So let's get into it. Let's draw the graph in 2 examples to see how it's going on, and then I hope you will be able to do it on your own and be able to do it in the future also. Now what you can do also is, since we are drawing stuff, you want to be as quick as possible. You can do most of these things using the calculator. So go in the calculator using the formula to get the x-intercepts, and also on the calculator you can find these two. But I'm gonna go by hand, everything slowly, so you can also see how it's done normally without the calculator, with some help of the calculator, not all of it. Okay, let's go into the task, example 1. In the first example, example 1, what we're going to do is we're going to draw a graph of the function f of x equals to, so f of x equals to x squared minus 2x minus 3. This is going to be the formula. Now, let's go and let's determine the coefficients. So a is equal to 1, because it's just x squared. There is just one x squared. B is equal to minus 2, and C is equal to minus 3. So let's use them, let's point them out. That's the reason why with the quadratic equation I wanted to point it out. Why? Because now we use it a lot. Well, now we use it a lot. Now, one thing I can ask you, for example, is without drawing the graph, do you know how the parabola is turned? Since the a is a positive number, parabola is turned upwards. So this would be the answer. So you already know how it should be turned, at least. Now let's go through the step-by-step process of finding out or calculating the things that we need. So we have to calculate the coordinates of the vertex. We have to find the coordinates of the zeros of a function, basically, or x-intercepts. We can determine what is going to be the y-intercept. Basically, this is going to be the y-intercept. And then go into the drawing itself. So, first step, I'm gonna mark them. There is no actual order, but I want to be organized, so let's go organized way. So let's start with the vertex. So it is going to be minus b over 2a. I'm just gonna copy one more time the formula. By the way, this formula you don't have to know by heart. It is in the formulas for state exam, so it exists there. You can use it. You can use it freely. You can copy it in their textbook and then use it from now on. And you don't have to know it by heart. So what I'm going to do, I'm going to concentrate at the beginning at minus b over 2a. Let's find out what this is, the value of all of that. So minus, I'm just going to copy this minus. B is minus 2, so minus 2 is instead of b, and 2 times the 1. Okay, minus and minus are going to cancel each other out. 2 is over 2, and the value is 1. Okay, so we found the x coordinate. I could also write it down like this, x is equal to. Meanwhile, y is equal to, let's go now, so this is the x, this is going to be the y. Meantime, y, I'm going to copy one more time the formula. I want to be precise, and I would encourage you to do the same. So 4 times 1 for a times c, which is minus 3, minus then b is minus 2, so watch out, this is the minus from the formula. Then we have minus 2 as another guy, and of course squared, because it's b squared, over 4 times the 1. Okay, let's continue on. I'm going to go in the next row, because I'm going to draw everything here. Now I can multiply 4 with 1 and minus 3. It's going to be minus 12 altogether. Minus then minus 2 squared is going to be 4. So minus 4 in the end, because minus inside of the bracket will disappear. Over 4. Let's continue on. Minus 12 minus 4 do not cancel 4 and 4. Do not cancel them. Okay, they have nothing in common yet. So minus 12 minus 4 is going to be minus 16 over 4. Now we can divide things. Minus 16 over 4 is going to be minus 4. If you're not sure or not certain, use the calculator to solve it. Now, of course, I'm going to point out that the coordinates of the vertex are 1 minus 4. So this is one of the points. Okay, I would say half of the job done. Let's continue on with the second step. Let's determine the zeros of the function. Let's determine the x-intercepts. So x1, 2, I can immediately use this formula. I don't have to go any further. I'm still using same a, b, and c, not changing, no changes there. So minus 2 for b, plus minus square root of minus 2 squared for b, minus 4 times 1 for a, minus 3 for c, and everything over 2 times 1. Okay, let's calculate this. So this is going to be 2 plus minus square root of, I'm going to immediately, now you can put everything here in the calculator to make it simpler. So this is all together going to be 16. Why 16? Minus 2 squared is 4. Minus is going to become a plus, so it's going to be 4 plus 12, square root of 16 altogether, which is going to give us number 4 over 2. We came into the situation where we can separate the solutions. One is going to be with a plus, the other is going to be with a minus. So x1 is going to be 2 plus 4 over 2, and x2 is going to be 2 minus 4 over 2. So this is going to be 6 over 2 for the first result, aka 3. So 6 divided by 2 is 3. Meantime, 2 minus 4 is going to be minus 2 over 2, and this is going to give us minus 1. Now we know x-intercepts. I'm going to point them out. 3 and minus 1. So we now have 3 points ready. We have 3 points ready. Let's go into the third step. Third step is simple enough. I'm not going to even do it somewhere on the side. Third step is here. Here we go. This is the third step. We have the y-intercept. C is equal to minus 3. So I can point out minus 3 on the y-axis, and I'm done. Now the last step is determining the point symmetrical to the y-intercept. Let's do it when we are drawing the graph itself. So let's draw the coordinate system. Just a second. Here we go. Coordinate system. You can try and be more precise than me because you have the grid. If you have the grid, it's simpler. I don't have the grid. I have to go by hand or looking at it. So 0, 1, and 1. Now, one thing you have to make sure, please, when you're drawing the coordinate system, this is the base you need to have. This is the base of the coordinate system. So we know we're in the coordinate system. We need the x and y axis. We need the distance between 0 and 1 so that we know all the distances going on forward. Okay, let's start with vertex. X coordinate is 1, y coordinate is minus 4. So 1, minus 1, minus 2, minus 3, minus 4. So 1 minus 4, here we go. Here is the vertex T. Let's continue on with the intercepts, x and y. So, x-intercepts. 3 and minus 1. 3 is going to be 1, 2, 3. Here is the 3. And minus 1 is going to be here, minus 1. Now watch out, I've pointed out here that x1 and x2 are in order x1 to x2, x1 left, x2 right. It doesn't have to be like that. For example, in what I got here is that x1 is to the right from x2. Doesn't matter. The order doesn't matter. You have to point out correctly. That's the important part. Okay, so now we have these two. Next step is going with c is equal to minus 3. This is the y-intercept. Minus 3 is here. So we have now altogether 4 points. Now what? How am I going to get the last point? I'm going to go through it. I already have the symmetry, so to say. So if I go, the distance is 1. One more distance to the right. So this is distance of 1. Same distance to the right. And here is going to be the last point. Now now is the time. I have the 5 points. I have to connect them, but don't connect them with a line, meaning straight line. Okay, connect them with a curve. There should be a curvature. So what I'm going to do is I'm going to do it like this. This is the base. Now, if you draw it like this in any exam, state exam or school exam, doesn't matter, you cannot get the full points because parabola extends into infinity. this seems finite. It doesn't seem infinite. So what you have to do is just continue on the curve. Just continue on how it would go on. Just have a feeling on how it would go on. And go as far as you have drawn the coordinate system. Don't stop it before. There is an assumption, there is agreement that we have to draw until the end of coordinate system, so we let know whoever is watching that it is continuing on to infinity. And this is the drawing of the graph of this here function. Here we go. This was one example. Let's look at another example. Example 2. Now, this time the formula is going to be f of x is equal to minus 1 over 2 x squared plus x plus 4. Now, one thing I would encourage you to do is, if you have issues with fractions, for example 1 over 2, rewrite it down in decimal form. How you do it? How can you do it if you're not 100% sure? Well, put it in the calculator, divide 1 with 2, and you're going to see the result. It may help you, it might be easier for you. So let's do it. So I'm going to first point out the coefficients. So a coefficient is going to be minus 1 over 2. I'm going to rewrite it down as minus 0.5. Why not? Then there we have only one x, which means that b is equal to 1. And the c, the free coefficient, is going to be 4. So let's go through the same process, same steps as before. Let's start with the vertex. X is equal to minus p over 2a. Let's implement everything that we know. Minus from the formula. 1 is b, and 2 times minus 0.5. Minus and a minus are going to become a plus. 1 is going to be multiplied. 1 is going to be divided by multiplication of 2 and minus 5. Should be simple enough. No changes there. So it's going to be 1 over 1, and it is equal to 1. We're done with that. Let's continue on with the y value. Now, y value is 4ac minus b squared over 4a. Now, let's implement everything. 4 times minus 0.5 for a times 4 for c minus 1 squared, okay, over 4 times minus 0.5. Now, of course, you can use the calculator to make it simpler for you. So when you multiply, I'm going to go in the next row. When you multiply 4 with 4 and with 0.5, you're going to get altogether 8, or minus 8 because of the minus before, minus 1 after this, and 4 times 0.5 or 4 times minus 0.5 is going to be minus 2 altogether. Now we continue on. This is going to be minus 9 over minus 2. Minus and a minus are going to cancel each other out, and we are left with 9 over 2, or if you're not 100% sure, going to the decimal form, 4.5. So now we know the coordinates of the vertex. It's going to be 1 and 4.5. Here we go. Let's go into the next step. Second, let's go on with the x-intercepts. So we go with x1, 2. Let's go with x1, 2. Okay, x1, 2 means minus b, which is 1, minus 1, plus minus square root of 1 squared, minus 4 times the minus 0.5 for a, times 4 for c, over 2 times minus 0.5. Okay, let's solve it. Minus 1, I'm going to leave it as it is for now. Let's solve what's going on in root. 1 squared is going to be 1. Minus and a minus are going to become a plus. 4 times 0.5, I'll lower together 8. Okay. Over 2 times 0.5 or minus 0.5. This is going to be minus 1. Watch out. Do not cancel minus 1 with minus 1. Do not cancel it. We have to solve everything beforehand. So minus 1 is going to be then plus minus square root of 9. Square root of 9 is going to be number 3 over minus 1. Time to divide them into sections, into the solutions. So x1 is going to be minus 1 plus 3 over minus 1. And x2 is going to be minus 1 minus 3 over minus 1. Lot of minuses. Oof. So minus 1 plus 3 is going to be altogether 2 over minus 1. Well, if we divide 2 with minus 1, we're going to get minus 2. And minus 1 minus 3 is altogether minus 4 over minus 1. Minus and minus are going to cancel each other out. 4 divided by 1 is going to be 4. And now we got the x-intercepts. The last and the third step is finding the y-intercept. And here we go. We have the y-intercept. Let me point out everything that we need. And we found everything. We know the vertex, x-intercepts, y-intercepts. Let's draw. Let's draw it. Coordinate system. I'm going to make it large enough now. I've got some room. Let me point out 0, 1, 1. Okay. Let's start with the vertex. So vertex is in 1, 4.5. 1 we already have on the x-axis. 4.5 is going to be between number 4 and 5 on the y-axis. So 1, 2, 3, 4, 5. So here's 4 and 5. 4.5, I'm going to say it's here. So vertex is this here point. This is the vertex. Here we go. Here we have it. This is the vertex. Let's continue with the x-intercepts. This means I'm going to point out the numbers on the x-axis. Minus 2 is going to be one of them. Minus 1, minus 2. Here we go. Here is one of the points. 4, 1, 2, 3, and 4. Here is another point. Now we have the x-intercepts. Let's find out the y-intercept. It is the 4. Here we go. Here is the y-intercept. Now how am I going to get the 5th point? Well, opposite to where the symmetry is going to lie. So this is the symmetry line. So opposite to it, this is the distance of 1. 1 more that distance of 1. So this is how far it is from the symmetry. That's how far we go to the right then. Here we go. Here is the last point. And now we can draw a curve. Make it curvy. There you go. And now we have a parabola that is turned downwards. Why is it turned downwards? Leading coefficient is minus 1 over 2. And this is today's lesson. See ya.